Assalamu alaikum students, this is the 7th video of chapter number 3 exercise 3.4 question number 1. In this question I will solve the last two parts. Part number 22, integral ln tan x secant square x dx. Putting ln x as first and secant square x as second function, integrating by parts we get ln tan x integral secant square x dx negative integral bracket integral secant square x into derivative of ln tan x dx. Ln tan x into tan x negative integral tan x into 1 over tan x into secant square x dx. Ln tan x into tan x negative integral secant square x dx. Tan x ln tan x negative tan x plus c. Moving on to part number 21, which is integral x sin inverse x over under root 1 minus x square dx. Putting sin inverse x is equal to t, which implies x is equal to sin t. Taking derivative of this function, we get 1 over under root 1 minus x square dx is equal to dt. Dx is equal to under root 1 minus x square dt. Putting the value of dx and sin inverse t in this function, we get integral sin t into t over under root 1 minus x square into under root 1 minus x square dt. 1 minus x square is cancelled by 1 minus x square, which leaves us with integral t sin t dt. Taking t as first function and sin t as second function, integrating by parts we get t integral sin t dt negative integral bracket integral sin t dt into derivative of t into dt. Now it becomes t negative cos t negative integral negative cos t into 1 dt. Negative t cos t plus sin t plus c. Now putting the values of sin t and t, we get negative sin inverse x into under root cos k t plus x plus c. Now putting value of cos k t, which is 1 minus sin square t, it becomes x minus sin inverse x into under root 1 minus sin square t plus c. Putting the value of sin, we get x negative under root 1 minus x square into sin inverse x plus c.